So a friend of mine had asked what it had taken to modify the Kasuntest ZT102 to get it up over 10,000 volts. So these were the final mods I came up with. You can see it's slightly different. I rearranged these parts, so I ended up putting the PTC on the bottom part of the board instead of laying it over the top, and then the resistor runs over the top. And now, rather than just the one layer of heat shrink tubing, you can see there's also a layer of Kapton tape. You can see there's also a small plastic spacer. It's located here, and you can see that kind of loops underneath the PTC and the series resistor. Another thing I had to do is grind out all the copper traces that were here for this fuse, and I did that on the top and the bottom side both, and I ground out all the vias. So basically that opens up all this clearance here. Another thing I'd done is I had cut this area out here, so this via is completely ground out. And I also ground out this trace, moving this away from the input jack. Again, just trying to give the input jack for the current and the common return as much clearance as I possibly could. You can see I've also cut a slit around the fuse holder here, and I inserted a small piece of Teflon. This goes all the way through the board. You can see by far this area has the tightest clearance. Also ground out all the copper in this area for the fuse holder. Again, if this were to break down, I'm just trying to give it as much clearance as possible between this jack and any of the ground or return points. Originally, when I started out the board, I had put a small MELF resistor in here, and what ended up happening, of course, is I had increased the transient levels. I ended up blowing that resistor open. So I replaced that with a small PTC, and this one happens to be roughly 500 ohms. And the whole point of that basically was if something were to break down in this area here, I wanted a secondary way to limit the current going back into our clamp. Unfortunately, I never went back and figured out how to modify the selector switch here to enable the microcurrent range. I'm not even sure if that could be done. So yeah, this should give you some idea what I ended up with. I think after our little drop test that we performed, another thing we could do is maybe put a little dab of RTV on this cap corner and possibly help secure that. I don't think the fuse would be a concern about falling out. First of all, this is butted right up against the top of the case, so that fuse can't move out this way. You can also see it's captivated on the two ends, but again, you can see just how tight this meter is in this area. And, you know, that's really the problem. I'm building it without even using a circuit board. It's just basically hanging parts out in free space. So again, this isn't really a good modification. It's not something the manufacturer could do. You'd really want to relay out this whole board. Maybe move the beeper to the other side or something and free up some of this area. So in the previous videos, after I had modified the Kasuntest ZT102, I never showed how the milliamp ranges worked. So currently all three of these meters are in series. You can see I'm applying 13 milliamps through them. What I'm going to do is turn the current up a little bit. You can see we're applying about 380 milliamps through them. Of course, the Fluke and the Bryman are pretty much dead on with each other. Kasuntest reads a little bit on the high side. So again, the resistors that we use for the shunts for this, I've pulled both of those out and I replaced those with a 1 ohm resistor. That resistor that I'm using is a 1% part. So it's adjusted on down. So you can see I've changed it over to the amps range. So the way this works is this is actually displaying 419.5 microamps. We can change the Bryman down to the microamp range. We'll do the same thing with the Fluke. Of course, that changes our burden voltage a little bit. So you can see all three meters are fairly close, about 359 microamps. And you can see I can turn the current on up, so this is basically 1.5 milliamps. And it switched scales, but one of the problems with having this in the actual amps mode, the way it's interpreting it, it thinks it's an overcurrent condition. We're all the way up to basically 4.1 milliamps right now. You can see we're all the way down to 78.5 microamps, and you can see basically all three meters are reading the same. You can see we're down at 1 microamp. And again, our Kasuntest is reading 1.0. It would have been nice if Kasuntest would have released the schematics for this. Again, I don't know if I could actually make this work anyway. It's very possible that you would actually have to add new pads or something to pull this off. Again, I never really spent a whole lot of time looking at it. Well, anyway, I hope that helps answer some of your questions as far as what I ended up with for the modifications on this Kasuntest. And until the next video, later.